happens is, in a word problem, you're given the everyday phrase most likely. You have to come up with the explicit translation in order to get the inequality. So when you're thinking about something like, a word problem below, somehow in there it captured the idea of an inequality. It's just how do you get that inequality out of the word problem onto paper so that you can solve it? That's the big question. And being able to explicitly translate something from an implied form. Fun fact, everyday phrases, for some reason, Common Core seems to think that you are capable of understanding the term explicit, but you are incapable of understanding the term implicit. Right? I figure if you know what one means, then you probably know what the other means. Right? So the root of implicit is implied. This is explanatory. The idea where you're detailing out the entire meaning of a word, leaving out nothing. Right? So that's a big challenge there. So nothing is left to your imagination, basically, when it comes to an explicit translation. I remember when I was growing up, we had the, well, you don't have it anymore, I don't think, but like music in movie stores. Like, because we couldn't just download music. Blockbuster, yeah. Blockbuster was big.
It's in the Captain Marvel movies.
Oh, yeah, it is. It's in the trailer. I saw it.
There's one in Stanford.
There's still one?
Yeah, it's really old and like kind of sketchy.
Yeah, but it's like probably a landmark now.
Yeah.
But like we would go to the mall, and if we wanted to buy like music, we'd have to buy a CD.
I still
What's
have
that?
I have so many CDs.
And you gotta understand,
So
CDs were only becoming popular when I was an adult. So when I was younger, it was those cassette tapes.
Oh my god.
Those were terrible.
Oh, we had those.
You had to like do the pencil.
I had, like,
Yeah,
the
you had to
old
wind it up and it got
cars,
loose.
You like put it in the like,
VHS.
and you like push it and you're like in a convertible and like it's just
Yeah, I mean those are the days. But anyway, whenever I would go to the music store, whatever it was called, like FYE, even before that, they would have labels on the music that would say explicit. It would say parental advisory, explicit lyrics.
Yeah.
So when I was a student, I'd walk in. I walked into this lesson as a student, thinking to myself, "Wait, does he want us to curse?" Because explicit in that context meant. So I'm like. I mean, there's a lot of ways I could jazz this up with a little bit of colorful humor, but and I went for it one time. It didn't end well. So me and the principal were acquainted with one another after that. But the idea behind explicit forms is that nothing is left to the imagination. All right. So when you're dealing with a word problem, a lot is left to the imagination. The idea, what you have to do is you got to parse that information. You have to take what's in the problem and pull out the relevant information and explain it in such a way that no detail is omitted. All right. Now, it is possible that sometimes there's extra information plugged into a word problem that is not meant for you to use. That's extraneous information. It's like when you have a word problem and they tell you that the temperature outside is 72 degrees, and you're like, well, I didn't need that for my solution. Why was it there? It's just there to throw you off. That can happen sometimes, but for the most part, you need to pull something like this from something like that. But that's actually not too difficult when the verbiage is simple enough. All right, so at least 6 glasses. X is going to be greater than or equal to 6. All right, in the interest of not defining our variables every step of the way, I'm just going to use X. X is less than 40. What's the next one?
X is less than 20.
X is less than 20.
X is less than or equal to 10.
Oh, words. I didn't catch any of them.
X is less than or equal to 10.
X is less than or equal to 10. The last one is the only one that could be categorized as possibly tricky.
35 is less than X is less than 120.
Yeah, boy.
When you like read it in a set here, X is greater than 35 and X is less than 120.
I say that this one is actually really tricky because between, I don't know. Can we assume this from that in all cases? I don't know. Like if we play the guessing game, like I'm thinking of a number between 1 and 10.
7.
Yeah, but here's the question that I'm going to ask. Is 1 and 10 fair game? If I say I'm thinking of a number between 1 and 10, is 1 and 10 a fair, if you said 7 and I said no, you're wrong, the answer was 1. You might come back and you said, no, you meant between 1 and 10. And I said, well, I was including the 1 and 10.
So you were doing it inclusively, but he was thinking extra.
Exactly. So I was thinking brackets, he was thinking parentheses. I don't know that you get parentheses necessarily from this, so we probably need some more information. And that information will be implied in the problem. It's not going to be explicitly stated. Right? It's not going to be stated in a straightforward way. So you have to pull that from the situation.
Imply implicit.
Exactly. Vocabulary. Magic. All right, sales representative is given a choice of 2 paycheck plans. One choice includes a monthly base pay of $300 plus 10% commission on his sales. Second choice is a monthly salary of $1,200. All right, that seems to be a flat $1,200. So that's what it is. Not getting any more. You could sell $150,000 worth of items. He's still only getting paid $1,200 for the month. So that sounds not good when you think about it that way. What's his incentive to work hard? For what amount of sales would the representative make more money with the first plan? All right, so let's start off with a let statement. Let X equal what? Number of sales? Amount of sales, yeah. And what would be the units for that? Yeah, money. Yeah, the units are money. It's the highlight of my life right now. It's all right. I knew what you meant, though. All right, so we have option 1. And we have option 2. Option 2 is the easier one to consider. It's okay. Right, option 2 is you get $1,200. Yeah. Option 1, we start off with $300. And then we're going to add to that some expression that's based on the amount of sales that are made. What would that expression be? 10%. All right, so let's address that for a second because I want consistent units. 10%
Equals 0.1.
equals 0.1. How'd you do that?
Because 100% would be 1, and then 10 of 100 is 0.1.
10%
Okay.
out of 100%, which is 10 equals 1.
It's a 10.
Out of 100%. Yeah, that's the key I was looking for.
Yeah.
And that's going to be equal to 0.1. All right. So, anyway.
That's distracting.
The term percent actually tells you what to do. All right, so if I have 10 and it's in percent form, that means it's 10 per cent. All right, cent is the root word of like century, centennial, things like that. Units of 100. Per is another name for division. So 10 divided by 100. Percent is actually one of those terms that actually tells you what to do. So we now know that 10% is equivalent to 0.1 multiplied by the amount of sales, X. I want to know when, in terms of sales, option 1 becomes better than option 2. When is not the best term to use because it usually references time, but it's good enough to get the job done here. So subtract the 300. Now, if I use an equal sign, that would give me a sense, of what the correct answer is, because that'll tell me when option 1 and option 2 are the same. And from there, you can infer what the correct answer is. But to show a complete inequality solution, I'll do it this way. All right, so we're looking at 0.1x equals 900 divide by a 0.1.
8.1x is less than, is greater
Oh,
than 100.
did it. I knew I was going to do it. Classic Bob.
Bob?
Yeah, it's an old TV show reference from Disney
Oh,
XD.
No.
No.
Disney come out.
Oh, Disney?
Disney
Like
is
1920s. Yeah.
No, Disney's
But Disney XD.
But I thought, what's his name?
Disney XD had like
Disney-
kicking
what's his
it.
name?
And
Disney.
I
Walt
love that show.
Disney?
Yeah, did he create that?
Oh, did I hear it?
What?
I thought I heard it.
Kicking
What?
it.
No, not that one.
Lab
Lab Rats.
Oh,
Good
I love
stuff.
lab
I know
rats.
that show. I know that show.
By the way,
Why rats came
you have the distinction of being the first class ever to get that reference.
I love lab rats.
Classic Bob.
What did you say? I wasn't paying attention.
It's the one.
All I said was classic Bob.
Yeah.
All right, so divide 900 by 0.1 and you get 9,000.
9K.
So
That's bad.
this is a word problem. Word problems typically require words at some point for a final answer. So we're going to say that Bob needs more than $9,000 in sales. Whoever it is. Need more than $9,000 in sales. All right. You got to be careful because, sometimes, and this happened before, people just say 9,000, they put a box around it, call it a day. Well, 9,000 won't get you more money for option 1. It gives you the exact same amount of money in option 1 as option 2. So that's not good. And in fact, what that's telling me, where are we working here? Yeah, okay, so we don't really have context here. If this is a car dealership, all right, $9,000 in sales, that happens with the sale of like half a car, so that could happen pretty easily. But if you're selling like software licenses or pencils, that could be a lot of work. All right, so depending on the context, this might be an easy thing to do, or it might be a monumental task. It might be something that's not easy to
But
get
still,
done.
it's $120,000 gig versus like $15,000.
If you can get it done.
Yeah. Oh, and that's $9,000 every month.
Yeah, on a monthly basis, $9,000 in sales every month. Now, if you're selling software, for example, software license for Microsoft costs about $300 per license. So, how many licenses, if it's at $300 a pop, how many licenses would I have to sell in order to get $9,000 in sales?
30.
30. So that doesn't sound like it's too bad. Those are group licenses. All right, but if I need to sell bulk rate pencils, and those pencils go at $50 a clip, so $50 to get, let's say, 150 pencils.
Wait,
It's personalized.
oh, like.
Oh, I only know this because I just researched it. Because I wanted to get them to say techcan.com on them. So, yeah, they are pretty expensive. You'd have to sell a lot of those in order to make your $9,000 in sales. So it might not be worth it in that context.
What if you work for
Oh, Timmy Turner's father. He sells pencils.
He does.
That's his job in the
Oh, yeah.
Oh, really?
Yeah, Timmy
Why are we
Turner's
talking
father
about
was a pencil miner.
All right.
No, Peter.
Worth looking into.
Or no, that's Homer.
All right. Number 2. To win the blue ribbon for heaviest pumpkin crop at the county fair, the average weight of John's 2 pumpkins must be greater than 819 pounds. One of his pumpkins weighs 887 pounds. What is the least number of pounds the second pumpkin could weigh in order for John to win the blue ribbon? All right, so let x equal what?
Weight of pumpkin?
Weight of just any pumpkin?
Second pumpkin.
Second pumpkin. He's a real big person in the
That's
business.
so gross.
All right, so one of the pumpkins weighs 887.
That's great.
887 pounds. All right, so that's huge.
It's a heavy pumpkin.
That is a very heavy pumpkin. The other pumpkin is some unknown weight. Question, how do I find,
It's already greater than 819.
It has to be the average.
so a 1 pound pumpkin's all I need? Nah, it's gonna be too little, most likely. All right. Yeah, in fact, if it's a 1 pound pumpkin, I'd have an average weight of 444 pounds. That's not gonna cut it. All right. I need to average out to 819 with some other pumpkin. How do I average?
You had 887 divided by 2.
Exactly. All dependent on how many values you had. If I had 2 more pumpkins for a total of 4, I'd be dividing by 4. All right, so this should average out to 819.
Well, it should be greater than 819.
Should be, I keep doing that. Quality control is what I need, fortunately.
Oh, yeah.
You're right there.
Yeah.
All right, so
Oh, for sure.
what's my next move?
Multiply by 2.
Multiply by 2.
We're close. We gotta get
Oh, no, I didn't.
So 887 plus x would be greater than, what is that, 1638?
Yeah.
Then I have to knock off the 887.
No, X is greater than.
751? Well, I subtracted 900 and then added 13, but I'm questioning whether I did it right.
751.
751? All right.
Woo! He's a math teacher.
Yeah, but like,
I mean, math teacher, intellectual savant, genius. I mean, you can use whatever term you want.
Intellectual
Fine.
savant genius.
Yeah.
like an academic.
So, final statement, least number of pounds the second pumpkin could weigh in order for John to win the blue ribbon. We don't have to write all of that, but we want to say second pumpkin must weigh at least, or you could say at least, or you could say it has to be greater than 751 pounds. Oh yeah, I'm sorry, not at least. So, second pumpkin must weigh more than 751 lbs, pounds. I'm writing the word pounds because I'm not going to worry about taking off credit on the test because we don't know scientific notation symbols. Not scientific notation, but science notation. All right. So once you come up with the equation,